For 9.1 day 2, we are going to be multiplying and dividing rational expressions. So we're going to take what we just did and we're just going to take it a step further. Now, for some reason, sometimes when this copies, these little boxes come up, they're just supposed to be multiplication. So if you ever see a box, that just means multiply. So let's think about this as just normal numbers, right? If we were multiplying fractions, what we would do is we would multiply 1 times 3, and then we would multiply 4 times 5. Then we would say 3 over 20 is our final answer. Now, you can definitely still do that in the next one. 4 times 15 over 3 times 16. I don't know why I put a parenthesis that time. You can, that still means multiply, right? But these things are not something that I know right off the top of my head, right? I mean, I can figure it out. We would have 60 over, and then 16 times 3 is 48. Okay, and then we would have to reduce it. Okay, and those reduced by 12, so you'd get 5 over 4. Okay, now, the thing that you can do, though, is think about it as one big fraction, kind of like what we have here. Once it's a big fraction, it's just stuff being multiplied. And remember, anytime you have stuff that's being multiplied, you can reduce. So if I have 4 times 15 over 3 times 16, I can take 3 and make it a 1 because 15 divided by 3 is 5. Same thing with the 4 and 16. I can get rid of the 4 and make the 16 4 because 4 over 16 reduces to 1 over 4. And then we multiply straight across for our final answer of 5/4. Now you're welcome to do it either route. I do think that this second way that I showed you is better, especially for what we're doing today. Okay, so remember, you can cancel diagonally and vertically, just not with anything that is included in the same spot, so not horizontally. Okay, so let's get into the core of it. So with number 1, it says we have x over x minus 1 and then x plus 3. So what I want you to think about is this being one big fraction when it's a multiplication. So now you can just start canceling things that match. We have an x and we have another x in the denominator. So those would cancel because that's 1. We also have x minus 1 and x minus 1, which also cancels. Nothing else overlaps, right? Especially like this 4 and the 2. I can't reduce that to 2 over 1 because that's not just a 2, that's x plus 2, and I would need that whole unit. So my final answer would be 4 over x plus 3 and x plus 2. In our next one, again, the box means multiply. This one's a little different, right? Because we have stuff that can be factored. So the first one in the top left can stay the same, right? And I'm going to make this one big fraction. And if we work our way to the right, the next one, t-chart it. First times last is negative 48. And we think what multiplies to 48, negative 48 adds to 2. That would be 8 and negative 6. So we can rewrite this as x plus 8 and x minus 6. The bottom left is the difference of squares. So take the square root, one's a plus, one's a minus. And then our bottom right, another t-chart. First times last is negative 32. What multiplies to negative 32 adds to 4. That would be 8 and 4, negative 4. So we have x plus 8 and x minus 4. So now we have a ton of things that are being multiplied, so we can start canceling. That means the 8s would go away, the x plus 8s. The x minus 4s would go away, and the x minus 6s would go away. So we are just left with the x plus 6. The problem is it's in the denominator, so it needs to stay in the denominator. So we have to put a 1 as a placeholder. Now, technically with all of these, we should talk about what all of our excluded values are. So for the first one, x cannot equal negative 3 or negative 2. And in this one, x cannot equal negative 6. Remember, all we have to do is say that the denominator is equal to 0, and that's what x can't be. So now we have number 3. For number 3, on the top left, we can take out a GCF of 2x, and we're left with x minus 1. On the top right, we would t-chart. First times last is 1, so it would have to be 1 and 1 to add to 2. So we have x plus 1 and x plus 1. In our denominator, on the left, first times last is 2. 2 times 1 multiplies to 2 and adds to 3. So we're left with x plus 2 and x plus 1. And then our bottom right, we can factor out a 4x, and we're left with x minus 1. So again, now's the time where we get to start canceling. We have x plus 1, and then we also have x minus 1 in the numerator and denominator. And then we also can reduce the 2x and the 4x. The 2 would become a 1, the 4 would become a 2, and the x's would cancel because x divided by x is 1. So now we can just rewrite it as a new fraction. We have x plus 1 over 2 and x plus 2. Now, if you put that 2 second, you can, but it's definitely better to put it in front. So number 4 says, what are my excluded values? So remember, we take our denominator and we set it equal to 0. So x cannot equal negative 2. So now let's talk about dividing. Dividing is exactly the same thing. But remember, when you divide fractions, you have to multiply by the reciprocal. So what that means is, okay, you multiply by the reciprocal. So we keep, change, flip. Might sound familiar. So we keep the first, change it to multiply, flip the second. And then we're back where we started. So this 2 would become a 1, the 8 would become a 4, and our answer is 4/3. So the same thing happens when we have ones like this. And this is a big one because students tend to have issues with it. So make sure you star it or highlight it in some way, shape, or form. So think about this still as 1 over 7 divided by 4 over 21. You're going to do the same thing. Or you can think about, all right, I need to rewrite this so the denominator moves up. Well, in order to do that, we're going to flip it around. So we would flip it around and then we would multiply. Again, we can cancel. So this could become a 1 and a 3. And our final answer would be 3 over 4. Okay. So again, keep, change, flip, multiply by the reciprocal, whichever way you feel like is easiest for you to remember. Okay, here's the general formula for them both. So let's work on dividing. And again, I'm going to move kind of fast through the factoring part because we have done factoring for a whole semester. So this first one, if I t-chart it, first times last is 2. And 2 times 1 would multiply by 2, multiply to 2 and add to 3. So that one becomes x plus 2 and x plus 1. Now I'm going to work in the denominator now. So if I do first times last, again I get 2. But I need a negative 3, so that would be a negative 2 and a negative 1. The big part about this is please make sure you remember if it is a division, we need to flip these. So I'm back to my numerator, which would be x minus 1 and x plus 1, because that's the difference of squares. And then our denominator becomes, first times last is 4, and it'll be 2 and 2 to multiply to 4 and add to 4. Now all we have to do is start crossing things off, right? X plus 2, x plus 2, x minus 1, x minus 1. And the other ones don't cancel. So we're left with x plus 1 squared, or you can write it twice. I'm not picky. And we have x minus 2 and x plus 2. Remember, if they ever ask for our undefined values, it would be at 2 and negative 2. X cannot equal 2 and negative 2. So number 6 is just like what we had before. Now the big thing is take your denominator and move it up, but flip it. So we're going to have a squared minus b squared over x squared minus y squared. And now that we flipped it, that means that we can now just multiply straight across. So x minus y can stay x minus y. Our denominator, a plus b, can stay a plus b. Our numerator in the other one would be a minus b and a plus b because that's the difference of squares. And our denominator would be x minus y and x plus y because that's also the difference of squares. And at this point, we can see our x minus y's cancel and our a plus b's cancel. So we're left with a minus b over x plus y. Couple more examples. On number 7, if you notice, you're probably thinking, okay, wait, we don't have a fraction, right? But think about it. Anything can be written as a fraction. Just put a 1 in the denominator. So if I start reducing that one, this becomes 2x minus 3 and 2x plus 3 because it's the difference of squares. Now this time, instead of flipping it right away, what I'm going to do is just write my factors over the top of it. So for this first one, first times last ends up giving me 36. And what multiplies to 36 adds to 12 would be 6 and 6. We put a 4 and an x in our denominator, and we can reduce both sides by 2. 3 over 2x, 3 over 2x. So this one is actually 2x plus 3 and 2x plus 3. Now our denominator, first times last, is negative 36. And what multiplies to negative 36 adds to 5. All right, so what multiplies to it would be 4 and 9, and it would need to be a negative 4. So we put a 6 and an x in the denominator and reduce by 2. So negative 2 over 3x. And this side's reduced by 3. So 2x plus 3. So this side becomes 3x minus 2 and 2x plus 3. So now what I'm going to do is flip them. So I'm going to put the blue in the numerator. And I'm going to put the pink in the denominator. Now, if it makes more sense for you to just automatically go there, please do so. You don't have to do it the way that I just showed you. But now if you notice, the 2x plus 3's cancel on both of them. So we're just left with 2x minus 3 and 3x minus 2. No fraction because everything in the denominator canceled. And now we have one last one, number 8. All right, I'm going to start by rewriting the denominator first. So this is going to be times, and we need the reciprocal. So forget about it down there. And now let's just start doing what we always do. And now we simplify. The 5x minus 2's, the 5x plus 2's, and that's it. So we have 4x times x minus 1 over x plus 1 and x plus 3. And that is our final answer.